Okay, question 6. Yay, more vectors. That's awesome. I do like a good vector, actually. Okay, right. So, equilateral triangle, classic triangle there. One with all the sides the same, all the angles the same. Guess that means all the angles are like 60 degrees. Sides and length 3. There you go. Vector R is too long. Perpendicular, I guess that's these right angle things, to both P and Q. Calculate the value of this scalar product. Right, P dot P plus Q plus R. How classic. P dot P plus Q plus R. Right, what's the first mark going to be? Easy first mark. Expand out the brackets, right? Just as you've been doing for years, right? P dot P plus P dot Q. Make sure, please, you put the dot in between all of them. That's important. P dot R. Okay, I don't really know what it means just to write PR. P dot R, I know what that means. It's on the formula sheet. Oh yeah, speaking of which, it's on the formula sheet, right? So here's the second mark, probably. What you're going to do for P dot P, it's the length of P plus, let's just break it up into sections. So this bit. This is going to be the length of P times the length of P times cos of theta, where theta is the angle between P and P. Now P doesn't really matter, but here it is. And here's P as well. What is the angle between this line and this identical line is 0. There is no angle between them. Okay, so this is going to be, oh, how long? How long is P? Side length 3, that's good. So that's going to be 3 times by 3 times by cos of 0. That's a 0. Cos of 0 is 1. Type on the calculator if you don't believe me. So you just get the number 9 for that part. That's good. So all I'm doing for every single one of these on the formula sheet, it tells you A dot B equals length of A, length of B, cos of the angle between. I'm just applying this to each of these in turn. P dot Q is going to be the length of P, which is 3, times the length of Q, which is also 3. It's an equilateral triangle. Times cos of the angle between them. Now this time the angle between them is an equilateral triangle, so it's 60 degrees. We spoke about that earlier. Equilateral triangle, 60-degree angles. So that's going to be 3 times 3 times cos of 60. Now, this could be non-calculator. You'd be expected to know that cos 60 is going to be root 3 over 2. No, it's not. It's going to be a half. That's nicer. Cos of 60 is going to be a half. You'd be expected to know that. But you can just type on a calculator to check in this case. So it's 9 times a half, or just 9 over 2. This one here. Length of P times length of R times cos of the angle between them. This is fun. Now, P is 3 long. R is 2 long. I don't actually care about that. I'll show you why in a second. Because see, these guys are perpendicular. Right angle 90 degrees. So I'm going to have 3 times 2 times cos 90. Now cos 90 be 0. There's nothing. That is times 0. Anything times 0 is a big fat 0. And that's why I didn't care how long R was, because whatever it is, times by 0, because cos 90 is 0, and I still get 0. Right, so what is the answer to the question that they asked me? Here's the question they asked me. It's going to be 9 plus 9 over 2 plus 0, which, I mean, 9 is the same thing as 18 over 2 plus 9 over 2, which is going to be 27 over 2. There we go.